Hello and welcome. We're glad you have joined us. My name is Amit Niyam. I'm a Microsoft technical trainer specializing in security and AI. I am here to walk you through the AZ-305 course, Design Infrastructure Solutions. In this session, we will cover Design a Network Infrastructure Solution Part 1. We will recommend a network architecture solution based on our workload requirements. We will design for Azure Network Connectivity Services, and we will design for on-premises connectivity to Azure Virtual Networks. So let's get started with the session. With Azure Networking Services, we can connect Azure resources and on-premises resources, protect and deliver our applications. To recommend a network architecture, we need to consider how workloads requirements translate to network requirements. Before we discuss any specific product, let's zoom out to understand our defense strategy. In Microsoft, we take a layered approach for defense. We don't bet our entire security posture on one thing like a firewall. In security, there's no bulletproof, but we can make it harder for attackers to break in by placing multiple controllers that hopefully will exhaust them so they will give up. In reality, if I have substantial amount of money, I'd want to store it somewhere safer than my house, most likely at a bank. At the bank, your money isn't simply left lying around the floor in the lobby for anyone to take it. When you enter, you're monitored. You must verify your identity to access your account. There are typically doors, sometimes several ones, that lead into the vault area. That may require a personnel card or even biometric verification to enter. Inside the vault room, you'll find your own cell, secured with your own unique key. We use the same logic in the cloud. By implementing multiple layers of security, we ensure that if one safeguard fails, another one is in place to protect our assets. All right, quick activity mode. We will look at the layers, the physical security, identity and access, the perimeter, the network, compute, application, and data, and try to match the Azure service that is the best fit for securing that layer. This is only a partial list. Think, what other solutions can help us protect our workloads for each and every layer? Keep in mind, we can mix Microsoft and non-Microsoft controls as long as they fit to our needs. All right, have you already come up with a solution? Let's see where each and every service fit. For physical security, this is considered from the data center point of view. For identity and access management, we can leverage privileged identity management and conditional access policies. For a perimeter layer, we can use distributed denial of service protection in Azure Firewall. For a networking layer, we can use application security groups and network security groups. For our compute layer, we can take care of the host security. For the application layer, we can use container security. And to protect our data, we can leverage Defender for Cloud for storage and information protection. Now, we will do the actual architect's job, gather requirements. Because architecture is like a map. You can drive without it, but you'll pay for the detours. Naming. The consistency helps operation. Naming convention enforced by a policy is highly recommended. Location, location, location. Where in the world we would like to work? Think about latency, data residency, compliance, resiliency, or legal requirement. Connectivity can be achieved across regions, but resources that are associated to one another must live in the same region, like my VNet, my VM, and its NIC. What about subscriptions? Are we working in landing zones architecture? Do we have a centralized subscription for connectivity? Do we need more than one? What about IP addresses and segmentation? We can segmentize by the network or by the subnet. How many IP addresses do we need per VNet? What ranges are already in use? We don't want overlapping ranges. How many subnets inside each and every VNet? What tiers do we have in our application? We better match those. Do we need a dedicated subnet for specialized services? The goal here is to reduce lateral movements. What about security? What must be private? What can be public? What needs inspection? Which components can communicate with one another? On which terms? How does traffic flows? Connectivity to the internet, from on-premises, between VNets, or even to another cloud. What about permissions? Who can create networks? Who can connect them? Who can change routes? Permissions are controlled through role-based access control. And policy. We can enforce our own decisions and standards with an automated policy to assure compliance. For example, to ensure non-overlapping address ranges. To enforce security rules by adding a network security group to every subnet. Or to peer a new VNet to the hub. After gathering the requirements, we can identify which design pattern for Azure Network Connectivity Services will help us meet them. Azure Virtual Network is the fundamental building block for a private network in Azure. It's an isolated portion of the Azure network where your resources can communicate securely. By default, all resources on the VNet can communicate with one another freely. In our design, we will take under consideration the communication between resources inside VNet, IaaS, and isolated paths, between other virtual or physical network, and outbound internet connectivity. The recommended and one of the most popular architecture network topologies is hub and spoke, a central hub for shared services like security, management, and connectivity with isolation for each and every workload. The hub is an Azure virtual network that acts as a central point for connectivity. The spokes are virtual networks that connect to the hub by peering. Shared services are deployed in the hub, while individual workloads are deployed in the spokes. Azure Peering provides a private connection on top of the Azure backbone, the optical fibers network that connects all of the Azure data centers for high throughput and low latency. So we can rely on private-to-private traffic between the spokes to the hub and secure the perimeter from the hub with Azure Firewall or distributed denial of service protection. That will work in the region or across regions, with different subscriptions or even across tenants. As long as we have permissions and there is no overlap in address ranges, we can connect them. Let's examine 3 common networking patterns for organizing our workloads in Azure. We can use a single virtual network. It's the simplest approach, but with limited isolation. We can create it within one region, define subnet for segmentation, protect with network security groups, and use application security groups to simplify administration. For example, Subnet 1 can contain our database workloads. Subnet 2 can contain our web workloads. To govern subnet traffic, we will use network security groups to specify that Subnet 1 can talk only with Subnet 2, and that Subnet 2 can talk back to the internet. We can deploy multiple virtual networks with peering or mesh. That provides us separation plus controlled connectivity. Here, we segmentize workloads by VNet, internally with subnets, and protect with network security groups. Connectivity between the workloads is explicitly granted while they have their own space to scale independently. We can plan for multiple virtual networks in a hub and spoke topology, an advanced pattern, isolated, centrally managed, and scalable. All traffic passes through the virtual hub, so it can act as a gateway to other hubs in different regions. The great thing here is that we set up our security posture at the hub. so we can get control and segment traffic between all the virtual networks. The scalability of this pattern is built in. As our network topology grows, the security posture overhead doesn't grow. Let's see a modern implementation of a hub-and-spoke topology. We will first deploy the centralized hub or secure virtual hub. We can do it in the dedicated connectivity subscription of the platform landing zones. We can maintain management services as Azure Bastion to connect to virtual machines without exposure. We can share hybrid connectivity over Virtual Network Gateway, VPN, or over express routes. We can centralize security with Azure Firewall to protect all of the connected networks and maintain protection from DDoS attacks. Our spokes are isolated and can be in the dedicated application landing zone subscription. They can contain infrastructure as a service solutions as well as isolated PaaS workloads. Outbound connectivity is sometimes neglected, but outbound is how your workloads reach updates, APIs, partners, and the internet. Network Address Translation, NAT, simplifies outbound connectivity for our internal resources. Our private IPs are translated to one or more static public IPs. As a reminder, default behaviors may change over time. Be sure to check on Azure updates for the latest announcements and plan ahead. We try to avoid situations where we wonder, why did our vendor block us? Oh, because our outbound IP changed and we didn't design egress. We recommend disabling outbound access altogether and explicitly allow only when required. For instance, a granular rule to allow Windows updates. That way, we gain better security, clarity, stability, minimizing disruption and risk. We can define NAT with Azure Firewall, Azure Load Balancer, Virtual Network NAT Gateway. Some examples of explicit outbound connectivity for virtual machines are public IP assigned per virtual machine. That can get quite expensive, not scalable, and harder to manage and govern. We can have a public IP allocated to the load balancer. This is great when our workloads are already working behind the load balancer. We can configure that with outbound rules. The best approach is public IP associated via a NAT gateway to the subnet. It provides us with fully managed, highly resilient, scalable, and secure outbound configuration by the subnet. Think of an airport. You first enter and go for checking. You can move forward with a ticket, but your next stop is not the plane, it's the security screening. You're following a specific, predefined path. This is what routes are for, to control how the traffic flows. To answer the question, where does traffic go next? We can use default system routes. Azure creates those automatically within the VNet, across subnets, and across peer VNets, and even more. You cannot edit system routes, but you can override them with your own user-defined routes. Routing can happen from within a single virtual network or across a hub-and-spoke topology. For example, traffic is entering into spoke 1, can be routed into the firewall for inspection, filtration, and only after that, route back into our backend spoke 2. Now we go hybrid. How do we connect on-premises networks into Azure VNets? Designed for on-premises connectivity to Azure Virtual Networks. Virtual Network Gateways or VPN gateways allowing us the most flexible option for connectivity. It allows us to create classic site-to-site connectivity between on-premises and Azure networks in a multi-cloud approach. It can also allow us to encrypt traffic between two virtual networks or allow point-to-point connectivity into Azure. ExpressRoute is a private connectivity option. Instead of riding on the public internet, your traffic goes over a dedicated, redundant, private connection via connectivity provider directly into the Microsoft network. It's like a private highway. You pay more, but you avoid the traffic jams on the public road. ExpressRoute allows direct connectivity into the Azure cloud on top of two up-and-running connections, always active mode. It can allow us to consume private traffic from our private network directly into our IaaS private workload networks, or to consume platform and even software services from Microsoft. ExpressRoute and Virtual Network Gateways are deployed on top of the gateway subnet. We can deploy both of them in the same subnet and allow high availability and option for failover. We can route private traffic through the ExpressRoute, avoid internet exposure for our most demanding workloads, and fail over if something goes wrong into a secure VPN connection. We can leverage the Azure infrastructure to connect all of our worldwide branches into Azure and allow full connectivity between them without investing in expensive infrastructure connection. It allows full any-to-any connectivity, so we can travel from our headquarters into one of the networks, connect through a laptop and reach to one of our branches, connect between Azure virtual networks, and basically any route that we will allow. It allows the full visibility and the routing capabilities in one single point of view. It relies in Azure on the hub-and-spoke topology and external connectivities through ExpressRoute and VPN gateways. In this session, we covered how to recommend a network architecture solution based on workload requirements, design for Azure network connectivity services, design for on-premises connectivity to Azure virtual networks. This concludes our first session of Design a Network Infrastructure Solution. Continue to Part 2 to learn more about network design considerations. There are many ways to continue your learning journey. We encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. I'm Amit New. Happy learning.